let's say that we're adding the mixed number 2 1/5, and we're going to add that to the mixed number 1 2/5. So 2 1/5 plus 1 2/5. So what does this mean, first of all? It means 2 whole pizzas plus 1/5 of another pizza, and we'll add that to another whole pizza plus 2/5 of another pizza. So I want to tell you in the very beginning, in the front end of this lesson, there's actually 2 ways to deal with mixed numbers when you're adding or subtracting them. The first way, when we're adding them here, is we can add the whole number parts, and then we can add the fractional parts and see what we get. Because we know we have 2 whole pizzas here, and we have another whole pizza here, so we know the answer is going to have at least 3 whole pizzas, but then we'll still have to add the fractional parts to figure out what fraction is left over. So we can add the mixed numbers just as they sit. But also another way to do it is we can convert this to an improper fraction and convert this into an improper fraction, and then we can add the improper fractions, and then we'll get the answer, and then we can change that to a mixed number if we want to at the end. The reason I'm going to show you both ways is because when we add fractions, you can kind of do what you want. Either way works. But when you subtract mixed numbers, it's going to be way easier to just change them to improper fractions most of the time. And so here in this lesson, you can have freedom to do what you want. I'm going to show you both ways, but just know that when we get to subtracting mixed numbers, it's actually going to be easier to change them all to improper first. So what do we actually have here? We have 2 1/5 and 1 2/5. So let's see what that actually looks like. So this 2 here is 2 wholes right here, and also 1/5 of a pizza, and so I can grab that. This is 1/5 here in green. So 2 wholes plus 1/5 of a pizza. That's how much I actually have here. And then this one is 1 whole. I'll kind of push that over to the side, and 2/5 here. So I'll have 2/5 right here. So 1 2/5, that's what that looks like. So what we're essentially going to do is take all of this pizza and add it to all of this pizza. Now we're going to, obviously we can see what the answer is just by looking at it, but how do we do it in terms of actually adding these guys together? What we can do is we can say, well, we know that 2 plus 1 is 3. We can just add the whole numbers, right? So we can say, you can do it, you can write it down any way you want. You can just say, here, let's go down here actually. We can say that 2 plus 1 is equal to 3, right? We know that 2 pizzas plus 1 more is 3. And then we can also say that 1/5 plus 2/5 we have to add. 1/5 plus 2/5. Now the denominator is already the same. And so the answer is going to be, the denominator will still be a 5, and then 1 plus 2 is 3. So if we wanted to put it all together, when we take both of these pieces of information that we have, the answer is 3 whole pizzas plus 3/5 of another pizza. And this is already simplified, so the answer is just 3 3/5, and that's the answer. Now, does this actually make sense? And of course it does, because if I add these together, then of course I'm going to get 3 whole pizzas, and then of course I have 1 2 3/5 of another pizza. So it's more than 3, and this is a little bit more than half of another pizza, 3 3/5. All right, so that is the way we do it when we're talking about just adding the mixed numbers together. I do want to show you how to change everything into improper fractions and do it that way, and so you can see that you'll always get the same answer. So we started with 2 1/5, 2 1/5. How do we turn this in to an improper fraction? You take the 2 times the 5, you get 10, you add 1, you get 11, and it goes over the same denominator. All right, and then we have the other fraction, 1 2/5. 1 2/5. How do we change this into an improper fraction? 1 times 5 is 5, 2 more is 7, and it's fifths. So this 7/5 is the same as this, and this 11/5 is the same as this. So we just take the 11/5 plus the 7/5, and we can add them in this form. You're adding the same things together. The denominator is the same as a 5. 11 plus 7 is what? 11 plus 7 is 18. So the answer is 18/5, right? But how do we turn this back into an improper fraction? Now, the way we've done it, I'll go ahead and do it one last time the long way here, but we're going to start kind of speeding up the process of converting this. 18 divided by 5, just take 18 divided by 5. 5 times 3 is 15, 5 times 4 is 20, so it has to be 5 times 3 is 15, and then we subtract 18 minus 15 is a 3. So what this is basically saying is when we do the actual division here, what it is it goes 3 whole times, and there's 3 pieces left over, and they're all in terms of fifths. So 3 and 3/5, which exactly matches what we got before. So you see, we can do it one of 2 ways. We can just simply add the whole number of pieces that we get to get a new whole number that sits in the front. And then we add the fractional pieces to get the fractional part, and then we just put them together. And then another way to do it is we take the first fraction and convert it to an improper, take the next mixed number, convert it to improper, add the answers, get the answer, and then turn it back into a mixed number, and you can see that you get the same answer both ways. So for a few problems, I'll do it both ways. But then beyond that, we'll just kind of pick away and do it. So I just want you to know that you have freedom to do either one. But when we get to subtraction, it's actually going to be easier to do it this way, and I'll save that for the subtraction lesson to show you why. But you just have to trust me. There's a reason why I'm teaching you this. All right, so let's move on to problem number 2. Let's take a look and say, well, what if we had 1 and 1/4, and I would like to add that to 1 and 2/4. Right? How do we do it? And what do we actually do? So 1 and 1/4. I'm going to steal this. This is 1 whole here, and 1/4 would mean this much. And I'll steal this one from over here. The 1 and 2/4 is this from right here, and then 2/4 would be, there's 1/4, there's 2/4. That's basically turns out to be another half, but that's 1 and 2/4, there's 1 and 1/4. So we're going to add them together. Now, what do we need to do is we can just simply add the whole numbers. We just know that 1 plus 1 is equal to 2. That's the whole number part. And then we have to add the fractions, 1/4 plus 2/4. The denominator is already the same. And then we add 1 plus 2 and we get 3/4. So putting both of these things together, the answer is 2 wholes plus 3/4, or 2 and 3/4. Does this make sense? And I think you see that it does, because if we actually add these together and push them together, scoot this over this way and add this over here, you get an answer of 2 wholes plus 1, 2, 3/4. 2 and 3/4. That's what you get. All right. Now what I'd like to do is work it the other way using improper fractions and show you how to do that. So if we start with 1 and 1/4, what do we get to change it to improper? 1 times 4 is 4, 1 more is 5, and it's always over the same denominator. That's 5/4. 1 and 2/4, right? What do we get here? 1 times 4 is 4, plus 2 is 6, so we get 6/4. All right, so now what we have to do is we have to add these together. So we have 5/4 plus the 6/4, and the denominator is the same as a 4. And then 5 plus 6 is 11. So we get actually 11/4. And that is the correct answer, but it is an improper fraction. Now to change it to mixed number, what we've been doing is doing the long division. We come down here and we actually divide it, and we can get the total number that goes in there and the leftovers and all that stuff. But we need to start to take the training wheels off a little bit. And we're going to kind of do this in our head a little bit. Sometimes we'll show it, and sometimes we'll do it in our head. Think about it. 4 times 1 is 4, so it can go 1 time at least. 4 times 2 is 8. It can go 2 times. But 4 times 3 is 12. That's too big. It cannot go 3 times. So you back up and you say, well, 4 times 2 is 8. It must go 2 whole times. But 4 times 2 is 8. How many is left over? Well, 11 minus 8 is 3. So you put a 3 right here. There's 3 leftovers, and it's always out of 4. This is the same process, and notice that this matches here. This is the same exact process of doing the long division. You know, when you take 11 and you divide it by 4, you say that it goes 2 times, and 4 times 2 is 8, and you subtract. And what do you get? 3. So it goes 2 whole times, remainder of 3 out of 4. All we do in our mind is we say, okay, 4 times 2 is 8, it goes 2 times, but the difference between 8 and 11 is 3, and then it always is over the same thing on the bottom. Notice you get the same answer here and here. So for the rest of the problems, we're not going to use any magnets, and I think I'll do 1 or 2 more times where I'll do it with the improper fractions. Most of the time, it's going to be easier just to add the whole numbers together and then add the fractional parts. So let's crank through the next problem. No more magnets. We're done with that. Let's take a look at 2 and 2/6, and we'll add to that 1 and 1/6. All right. So what we have to do is we have to add the whole numbers. So we know that 2 plus 1 is 3. And then we have to add the fractional part. So 2/6 plus 1/6. The denominator is a 6. 2 plus 1 is 3, and we get 3/6. Now we know we can simplify this. 3/6. We can divide top and bottom by what? We can divide both by 3. 3 divided by 3 is 1, and 6 divided by 3 is 2. And so at the end of the day, when we put all of this information together, we know we have 3 wholes, so the 3 goes here, and we have a half left over, 3 and 1/2. If you put 3 and 3/6, that would be correct as well, but then we'd have to simplify it to get down to 3 1/2. That's the final answer. Now, I want to quickly work this one again. Let's change them to mixed numbers. Let's do this one. 3, actually I wrote the wrong thing down. It should be 2. So let's write down 2 and 2, 6. How do we do an improper? 2 times 6 is 12. 12 plus 2, 14 sixths. And then we have this one, 1 and 1/6. 6 times 1 is 6. 1 more is 7 6. Now we have to add these fractions together. So we have 14 sixths plus, what do we have here? 7 6. The denominators is 6 because they're the same. And then 14 plus 7, when you add that, 14 plus 7 is 15, 16, 17, 18, 19, 20, 21. 21 sixths. Now you could circle that as the right answer, but let's change it to mixed number. How many times can 6 go into this? 6 times 3 is 18, and 6 times 4 is 24. That's too big. It can only go 3 times. 6 times 3 is 18. But the difference between 18 and 21, 19, 20, 21, is just 3. And it always ends up being over 6. So you write 3 and 3/6. But then 3/6, just like we showed here, it becomes 3 1/2. You divide the top by 3 and the bottom by 3, and you get exactly the same thing, 3 1/2. So that's probably the last time for a while that I will do it both ways. I'm just trying to reinforce to you that you do have freedom when you add mixed numbers to do it either way you want. All right, next problem. Let's take a look at 2 and 1/4 plus 1 and 1/2. Now here we have a problem because we have the 1/4 and we have the 1/2. We do not have the same denominator. But what we can do, first of all, is we can say 2 plus 1. We can say that 2 plus 1 is 3. Okay? And then we can write the 1/4 plus the 1/2. But these are not the same denominator. How do we change it to the same denominator? We can make it a 4 by multiplying this one by 2 over 2. So I'll have 1/4 plus 1 times 2 is 2, and 2 times 2 is 4. All right, we have the same denominator. And then 2 plus 1 is 3, and so we get an answer of 3/4. So when we put all this together, we get an answer of 3 3/4. And that was the final answer, 3 3/4. So all we do is we add the whole numbers and get that answer. We add the fractions, but we know we have to find a common denominator, and then we can't simplify this, so then we just put them together. Now, I'm not going to do it here, but I promise you, if you convert this to an improper fraction, and you convert this to an improper fraction, and then add them, and then change it back to a mixed number, that is exactly what you're going to get. All right, let's take a look at the next problem, problem number 5. Actually, I think I want to do that one on the next board. Problem number 5, let's take a look at 1 and 1/8. And we'll add to that 1 and 1/4. All right, 1 and 1/8 plus 1 and 1/4. So first of all, let's go ahead and just add the whole numbers together. We know that 1 plus 1 is just 2. 1 plus 1 is 2. And then we have to add 1/8 plus 1/4. We have an 8 and we have a 4, and we need a common denominator. So what do? We change this to an 8 because we have an 8 right here. So we multiply by 2 and multiply by 2. And so we have 1/8 plus, what is this? 2/8. And we add those fractions together. What do we get? 8 on the bottom, 1 plus 2 is 3. And when you put them all together, 2 whole pizzas and 3/8 of another one. 2 3/8, that's the final answer. All right, I lied a little bit. This will be the last time that we will do it both ways. We'll solve this problem again, and we'll say that 1 and 1/8, let's change that to improper. 8 times 1 is 8, 1 more is 9, so this becomes 9/8. Here, this one, 1 and 1/4, is going to be 1 times 4 is 4, 1 more is 5/4. So we need to add these, 9/8 and 5/4. but these do not have the same denominator, so what do? We change this fraction because we can change it into an 8. So we'll change that by multiplying by 2 and multiplying by 2. And so what I'll have is 9/8 plus 5 times 2 is 10, and 4 times 2 is 8. Now we add these numbers together. And so what do we get? We get an 8 on the bottom, and 9 plus 10 is 19. So we get 19/8. Now let's try to convert this without doing long division here. So what do we have? How many times can it fit in there? 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. That's too big. So it has to be 8 times 2, which is 16. Can fit 2 times for 16. But the difference between 16 and 19, 17, 18, 19, the difference is 3 out of 8. So you get an answer of 2 3/8. Same exact thing. The only real difference here is that once we got the improper fractions, we still have to get that common denominator to add there. So I think at the end of the day, we will stop doing it both ways. At this point, we'll just kind of we'll just accept that we can do it both ways. All right, next problem. Let's take a look at 2 1/4 plus 1 1/12. All right, so what do we have? We know that 2 plus 1 is 3. Last time I checked, 2 plus 1 is 3. And then we have the 1/4, and we have the 1/12. So we have a 4 and a 12. How do we get a common denominator? Well, the simplest way to do it is just to multiply this by 3 and this by 3, because 4 times 3 is 12. And so this fraction will turn into 3 on the top and 12 on the bottom. And we still have to add the 1/12. So we add these, we get a 12 on the bottom, and then 3 plus 1 is 4. 3 plus 1 is 4. Now we can simplify this, right? Because we can divide top and bottom by 4. So the 4/12, we can divide the top by 4. We can divide the bottom by 4. And what we get, 4 divided by 4 is 1, and 12 divided by 4 is 3. So it comes out to 1/3. So when you put all of these things together here, what do you get? 3 and what? 1/3. 3 and 1/3. This is what it actually equals, 3 and 1/3. That's the final answer. And we could go and do it the other way, convert to improper and all that, but we're going to get the same answer. We're just kind of picking one path forward as we do these now. All right, only 2 more problems. Let's take a look at 3 7/8, and we'll add to that 1 1/2. Now this is an interesting problem. I really want you to take a minute to follow through every little step of this. What do we have here? The whole numbers, 3 plus 1 is 4. So we already know that. Let's add the fractions. 7/8 plus 1/2. We want to add them. The easiest way to get a common denominator is to multiply this by 4. 2 times 4 is 8. So that's what we're going to do. We're going to take this second fraction, and we're going to multiply it by 4, like this. And what are we going to have? The 7/8 is here. And then we have 4 on the top, and 2 times 4 is 8 on the bottom. So what do we get? The denominator, the common denominator is 8, and 7 plus 4 is what? 11. So we get 11/8. Now look at this. Normally what we would do is say, let's go back to the previous problem. Let's say we got a 2 plus a 3/8, 2 3/8. We got a, over here we got a 3 and then a 1/3, so we put them together for a 1/3. Here we had a 2 for a whole number and the 3/4, so we put them together here. But notice this was an improper, proper fraction. This down here was a proper fraction. This was a proper fraction. This was a proper fraction. But what we got here is an improper fraction, 11/8. 11/8 is already bigger than 1. So what do? Let's convert this 11/8 straight away. Let's convert this to a mixed number. So let's convert that. 8 times 1 is 8. It can go one time at least. 8 times 2 is 16, but that's too big. It can only go one time. So 8 times 1 is 8. And what's the difference between 8 and 11? 9, 10, 11. 3 is the difference out of 8. So we convert this to 1 3/8. Now what we do is we put both of these together. What we have is 4 plus 1 3/8. We have this as the whole number of pizzas from our problem. But, from our problem. But when we added the fractional parts, we actually got something bigger than 1. So now we have 4 whole pizzas plus another whole pizza plus 3/8. And what is that? That is 5 3/8. 5 3/8, and that's the final answer. Now, why did it do that? Why did this one happen that way? It's because 7/8 of a pizza means you have 7 slices out of 8 total. So it's almost a whole pizza by itself. And then here you have another half a pizza. So if you put something that's almost a whole pizza together with another half, the fractional bits, when we add them together, come out to something more than one whole pizza. So whatever you get, you just add the wholes to the other wholes you had, and basically you get the total number of wholes, and so your final answer is 5 3/8 in this case. Now we're going to see that in the next problem. The next problem, I'll give you a little bit of a spoiler alert. We're going to see the exact same thing happen in the next problem. Let's take a look. What about 4 1/3 plus 3 5/6? Now let's see if we can predict. We have 5/6 of a pizza here. That's almost a whole pizza, 5 slices out of 6. And we're adding to it another third of a pizza. So when we put the fractional bits together, that's already going to give us something more than 1. So the same thing is going to happen. The first thing we do is we add the wholes. 4 plus 3. 4 plus 3, that equals 7. And then we have the fractional parts, 1/3 plus 5/6. Now, the denominator I have is a 6 here, so I'm going to change this one. The easiest way to do it is change this by multiplying by 2, and I'll get a 6 as a common denominator. So 1 times 2 is 2, and 3 times 2 is 6. I'll add that to the 5/6, and what do I actually get? The 6 stays on the bottom, and 2 plus 5 is what? 7. Notice I got an improper fraction. That means this is something bigger than 1. That's what that means. Let's convert it here. 6 times 1 is 6. That's as close as I can get. 6 times 2 is 12, so that's too far. It can only go one time. 6 times 1 is 6. I have 1 left over because 7 minus 6 is 1, and then it's going to be over 6 again. So I have 1 and 1/6, and then I have to add it to what I got here. So I'm going to have the 7 plus the 1 and 1/6, and so I'm going to get an answer of 8 and 1/6. And that's the final answer. I cannot simplify it anymore. And so what's happening here is the fractional bits add up to something bigger than 1. If that ever happens, just add the whole numbers to what you have, and that's the way it works out. It sometimes that happens. If you ever get an improper fraction at the end here, when you do it, just don't flip out about it. Just turn it into mixed number and add it to what you had to begin with. So we've been adding mixed numbers here. Sometimes we have a common denominator already. Sometimes we have to find a common denominator. We can add the whole number parts together and then add the fractional parts together, and then we can get the final answer that way. Or we can do what we were doing here in the beginning, where we do it an alternate way, where we change the mixed numbers to improper fractions, add the improper fractions, and then change it to a mixed number, and we always get the same answer no matter what we do. So when you're adding mixed numbers, you have freedom in which way you want to do it. When we subtract fractions, mixed numbers, later on, I will show you why it generally makes more sense to turn them into improper fractions when we do the subtraction. We'll get to that part when we get there. For now, practice these yourself. Follow me on to part 2. Let's get a little more practice with adding mixed numbers. Learn anything at mathandscience.com.